All right, so here we have it written up formally. This is the power rule. Again, probably if not the most important rule when it comes to differentiation. How do you find the derivative of x raised to any power? You drop the power down in front and make it a coefficient, and then you raise it to that power minus 1. I do want you to just notice that the derivative of x is the derivative of x to the 1. So that would be 1x to the 0. 1x to the 0 is just 1. So what's the derivative of x? The answer is 1. What does this allow us to do? This allows us to find a lot of derivatives very quickly, and even derivatives that you might not think you could find. This one, 3a, f of x equals x to the 4th. What's the derivative of that? Well, that's x to some power, isn't it? What's the derivative of f to some power? Notice I'm writing f prime of x equals, drop the power, you keep x, and then you do the power minus 1. So what would that be? That would be 4x cubed. That's the derivative of x to the 4th. Oh my gosh, that is so much easier than doing the limit as h approaches 0 of f of x plus h minus f of x all over h. The limit process is no longer necessary, unless the problem specifically states it. Find the derivative using the definition of derivative. You can use the power rule every single time. So only use the definition of derivative if it asks to. Otherwise, we can use the power rule and save ourselves tons of paper and tons of time. What you're going to find out quickly is this rule, the derivative of x to the n, drop the power and then raise it to the power minus 1, works for a lot of functions. It doesn't just have to be a polynomial function. It can work for radical functions as well. As long as you did that algebra review packet, you would remember that the square root of x is really x to the 1/2. And one of the things that I emphasized in the exponential review packet is you have to be comfortable going from radicals to exponents and exponents to radicals. So here we started with the square root of x in radical form. We changed it to exponential form. Well, now it's x to some number, right? So if I want to find the derivative of this, what I do is I drop the power, I take x, and I do it to the power minus 1. It works even if that number is a fraction. It doesn't have to be a whole positive number. It works for any number. So this would be 1/2 x to the, and I beg of you, please, with your fractions, use your calculator. A lot of you think you know how to do 1/2 minus 1. Well, I'll tell you what, on test day, that's where the math errors happen. It's not in the calculus. It's not that you don't understand to drop the power and then subtract 1. It's that you can't do 1/2 minus 1 without a calculator. So that's why I allow a calculator. Please, by all means, use it. 1/2 minus 1 is negative 1/2. Well, we got a little bit of an issue here. There's two issues. If my original problem starts as a radical, then my final answer needs to be a radical. Second thing is I can never have a negative exponent in a final answer. So again, with that algebra review, you've got to remember how to handle negative exponents. When you have a negative exponent, it takes the variable and it throws it into the denominator, and then it makes it positive. So if I took this x to the negative 1/2 and threw it into the denominator, I'd have a 1 in the numerator. My 2 would be in the denominator, and I'd also have an x to the 1/2 in the denominator. I'm still not quite done on this one because, again, if it starts as a radical, it needs to end as a radical. So what would I do? I would make this 1/2 times the square root of x. That would be my final answer because the power of 1/2 is a square root. So there it is. The derivative of the square root of x is 1/2 root x. I ask that you go back to the previous section that we did with limits and finding the derivative of square root of x using limits. If you remember, the limit as h approaches 0 of f of x plus h minus f of x all over h. We had two radicals in the numerator. We had to multiply by the conjugate and do all sorts of algebra and simplification, and we ended up with the same answer we just did right here, right now. So the power rule, love it, cherish it, because it will treat you well. It saves you a whole lot of trouble trying to find derivatives using the definition of a derivative. Let's keep on going. Even something like this, C is y equals 1/x cubed. How do we find the derivative of 1/x cubed. Well, the power rule only works if the variable is in the numerator. Here we have the variable in a denominator, but if you're comfortable with your powers, you know if you want to move something from the denominator to the numerator, all you have to do is take that exponent and make it a negative. So in other words, 1 over x cubed is really the exact same thing as x to the negative 3. It's really 1 times x to the negative 3, but the simplified version of that is x to the negative 3. So now we're asked, instead of finding the derivative of 1 over x cubed, we're finding the derivative of x to the negative 3. Well, that's x to a number. So we know, using the power rule, that the derivative would be, drop down that power, negative 3, and then you would take x to the negative 3 minus 1. Again, I beg of you to use your calculator. A lot of people on this would say negative 3 minus 1 is negative 2. If you use a calculator, you'll never make that mistake. Negative 3 minus 1 is actually a negative 4. So this is negative 3x to the negative 4. Again, we have a bit of an issue, though, because we still have a negative sign in our exponent, and no answers can have a negative exponent. So what would this be? Anything with the exponent negative, you have to throw it into the denominator. This is another thing that I emphasized in the exponent or the algebra review packet, is that what actually comes down. If you notice, there are not parentheses around the negative 3x. The only thing raised to the negative power is the x. So that means that coefficient, negative 3, has to stay on top. And the x is what comes down to the bottom. Make sure that negative 3 stays on top. It is not raised to the negative power. You do not bring it down. If there's no parentheses around it, it doesn't go to the bottom. Negative 3 stays on the top. X to the 4th goes to the bottom. So what's the derivative of 1 over x cubed? The answer would be negative 3 over x to the 4th. We can get even nastier with it. How about combining parts B and part C, radical and throwing it in the denominator? Don't fear, as long as you know how to convert radicals to exponents and how to handle negative exponents, you're going to be good here. So this is the exact same thing as 1 over, well, the 4th root of w to the 5th. If you remember, the exponent stays the numerator, the radical is the denominator. We went over this in the algebra review. So this would be w raised to the 5/4. So again, here we have an issue because it's in the denominator, but we can simply move this to the numerator as long as we make that power negative. So this would be w to the negative 5/4. Again, it's really 1 times w to the negative 5/4, which is just w to the negative 5/4. So we don't want to find the derivative of 1 over the 4th root of w to the 5th. We want to find the derivative of w to the negative 5/4. We've rewritten it into exponential form in the numerator. What does that allow us to do? That allows us to use our power rule. So the derivative of g, and I want to be very specific. If you notice, every single time, I cannot put an equal sign between these two things because they're not equal. I have to write the derivative of it equals. We drop the power. That would be negative 5/4 w to the negative 5/4 minus 1. Again, I beg of you, please, 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 I allow a calculator, use a calculator. This would be negative 5/4 w to the negative 5/4 minus 1 would be negative 9/4. We have a negative exponent. What's that mean? Negative exponent means we need to throw it into the denominator. What comes into the denominator? Well, the negative 5 stays in the numerator. The 4 stays in the denominator. So my derivative here is equal to negative 5 stays in the numerator, 4w to the positive 9/4. When you throw it in the denominator, that power becomes positive. One last thing. We can't have, if we started in radical form, we need to end in radical form. So what is 9/4 as a radical? Remember, the numerator gives you the exponent. The denominator gives you the radical. So this would be negative 5 over 4 times the 4th root of w to the 9th. There it is. Negative 5 over 4 times the 4th root of w to the 9th. It's a mouthful. It's just algebra. I want you to take a step back. This is something I'm going to make you do numerous times this semester. Number one, appreciate the power rule, because can you remotely imagine trying to do this with limits? So you got to respect the rules. You got to love the rules. They save you a total ridiculous amount of time and space and effort. Second thing, what I really, really want to emphasize is calculus is easy. You're going to hear me say that numerous times this semester. I want you to think about this entire problem. Where's the calculus in this problem? The only calculus involved in this problem is between these two steps. What is the calculus? You dropped the power and you subtracted 1. That is calculus. Drop the power and subtract 1. Every single thing else you see on this page is simple algebra. I'm not going to say simple. It is algebra. So if you're comfortable with your algebra skills, I am telling you, calculus is easy. Drop the power and subtract 1. It is those algebra skills that make you sink or swim in a calculus course. Okay, let's keep on going. It says, so for any problem where x is in the denominator, use the negative exponent property. In other words, if it's in the denominator, bring it to the numerator and make that power negative. For any problem where x is underneath a radical, if you see a radical, convert the radical to exponential form. Remember that the numerator is the exponent and the denominator is the radical. It says, however, in this case, be sure to simplify your answer. There's no negative exponents, and or convert it back to radicals. So here's a couple examples. How would you handle finding the derivative of 1 over x squared? Move it to the top. That'd be x to the negative 2. Now you can use the power rule. Drop the power, subtract 1. But then you have to remember you can't have a negative exponent in your final answer. So you have to do that one last step of flipping that x cubed back to the bottom. Same thing, what's the derivative of the cube root of x to the 4th? Well, that's x to the 4/3. Again, the exponent is the numerator. The radical is the denominator. Now that it's in exponential form, I drop that power and I subtract 1. So there's dropping the power and subtracting 1. 4/3 minus 1 is 1/3. But you can't leave it like that because it started in radical form. You need to end in radical form. So that'd be 4/3 times the cube root of x.